Thanks for the start there, Josh. Yeah. Okay, we are continuing on with review exam practice 2.7 from your Jack textbooks. We are looking at representing vectors in the plane. We got up to question 6 in yesterday's video, so we're going to start with question 7 today. Make sure that can actually be seen in today's. No. Might just start a little roll. All right. Question 7. We are given the two vectors A and B. A, can you just read that out to me so I don't have to keep going? Are you looking at it as well, Josh?
Question 6.
7. What's vector A?
That's vector P.
Am I on the right? Are we in the same thing? 2.7 review exam practice 7. Are you in complex numbers by any chance?
No, I'm at application of vectors. I'm not.
You're in the wrong chapter.
Yep.
Chapter before. Okay. So our vector A there is 3i minus 5j. Vector B is negative 4i plus j. So negative 4i plus j. Okay. So we've got our two vectors. And now we've got 5 things to do with them. The first one is a nice, simple vector addition. So this is now part A of question 7. We are asked to do vector A plus vector B. Can you remember how to add vectors, Josh?
Multiply the I and j components together.
A plus B. Are we going to multiply them? What if I drew a little diagram? If you remember, okay, and this isn't going to be accurate, I'm just drawing two vectors. If I have from origin vector A, and I have from origin vector B.
Oh, head to tail.
Head to tail, yep, so what do I need to do?
Move and connect the vectors from tail to head.
Yeah, which one do we normally do though? If I'm doing A plus B,
Put B on the head of A.
are you sure? Because I'm always trying to trick you. I'm always trying to trick you.
No. Put A on the head of B.
Put A on the head of B.
No.
If we were doing the vector A to B, then that is what we would be doing. So that's what you missed in yesterday's video. We did a couple of questions in this. In this one, we are adding the vectors A and B, not going from A to B.
Yeah.
Okay? So I drew that in there and I thought maybe we'd get a little bit confused and we want to go back to that first one. How do we add them? I think you were getting closer to the right answer to begin with.
Okay.
Combine your I components, combine your J components. Okay?
No.
So for this one, we've got our first one, 3i minus 5j plus negative 4i plus j. 3 plus negative 4 gives us negative I. Negative 5 plus 1 gives us negative 4. That is how you add the vectors A and B. This is going to be the one I'm going to get, G. Are all the new ones Dells?
Potentially. It's not a bad one.
Okie dokie. What do we got next? Next is A minus B. So part B, this time we're doing vector A subtract vector B. And so you could do this either with your subtract out front, which I think is probably getting easier these days for you guys. Although sometimes we will add the reverse. I'm doing A minus B. So there's my vector A, and now I'm going to subtract everything that is a vector B. Okay, so this time we're doing 3 minus negative 4, so it becomes plus 7i. Negative 5 minus 1 minus 6j. Nothing too fancy or complicated there. I'll do C and I'll clear myself some space. This time I believe we want the dot product of A and B. So we went through this in yesterday's video. We set up the different ways you could do it. I certainly find the easiest way to be combining your i's and your j's rather than using your cos and your magnitudes. So let's just do that one. My dot product here, we write as x1, x2 plus y1, y2. Okay, where your x's are your I components and your y's are your j components. So we're going to be doing 3 multiplied by -4 plus -5 multiplied by 1. 3 times -4 gets you -12 minus 5, because we've got -5 times 1 gives us -17 is the dot product of A and B. Leave that up for just a sec. And probably start erasing from the top, can't I? Leave my 2 vectors up there because we're going to need to use them again. You got C down, Josh?
Yep.
Sweet. What did they ask us to do next? Well, what is that? What is that little symbol there? Come in. Can you remember? A hat. I'm not calling you names, I'm trying to remind you.
We had English last period, right?
Yeah. Hang on, is this going to be still out? I'll just pause this for a sec.
Yesterday I had students.
All right, we're back on film. A hat. Have you remembered? Can you help him out, Indy, now that you've joined us?
No,
No? What's this, guys?
A hat.
Unit vector.
A unit vector.
A unit vector, okay? A hat is the unit vector of A.
Plus J.
We calculate our unit vectors by taking vector A and dividing it
Oh yeah.
by the magnitude of A.
Let's be honest.
Wiggle that? Like once that happened, you took it off, but anyway. Okay, so we've already got vector A, we need to calculate its magnitude. How do we calculate a vector's magnitude?
With the I and j components.
Yeah. So in this case, we've got root of 3 squared plus -5 squared. Root 9 plus 25. Root 34. We might just leave it at that. You could probably take a 4 out. What's that? No, it's Thursday, that's Tuesday.
Yeah, but
Okay, so that's just part 1, guys, because you need to find your magnitude. After that, you're going to now be able to calculate your unit vector. I'm not getting too low, so I'm going to come over here. So my unit vector A, which is equal to the vector divided by its magnitude, is going to be 3i minus 5j all over root 34.
oh, sorry.
Hello, no, you're right. So let's go 3 on root 34i minus 5 on a root 34j. And that would be your unit vector.
You'd probably have to convert them though, sir, because you should have an irrational one.
Yep, so how do we do that, guys?
Multiplied by the root.
Yep. So this is a bit nasty here, so let's do it in the step above and clean it up. It'll make maybe it is easy to do it one at a time. Because we'll just end up with the same thing, won't we? Yeah, let's just do it this way. Root 34 over root 34 is going to equal root 34 outside of 3i minus 5j all over 34. And write that as root 3 times root 34i over 34 minus 5 lots of root 34j over 34. Let's have a look at E. Last one in this set of 7. And again, a really good question because A, B, C, D, and E are now all of the main things you need to do with your vectors. We'll have a look at a couple more in a sec, which is going to be your midpoint and your resolutes. But that covers a lot of our major operations between two vectors. Okay, so for E, we're looking for the angle between vectors A and B. Indy, you were here yesterday. How do we calculate the angle between? Just cos theta. What was that, sorry? There's some magnitude in it, yep. Dot product divided by the magnitudes multiplied by each other. Okay, angle in between. So we've actually got the dot product for A and B. We did that in one of our previous questions. I believe it was negative 17. Is that right?
Yeah.
Yeah, just to save ourselves some time. And obviously, if we want to get theta, we're going to have to rearrange this to get inverse cos. So we know that that's going to be 17 on top. Oh, sorry, negative 17, because we've already calculated the dot product of AB in a previous question, so we can just go ahead and use that. And then I'll just take a little side by over here. Actually, we've got the magnitude of A as well. What did we work that out to be?
Root 34.
Did we do magnitude A? Oh, just for the unit vector, right, yep. Okay, so that's our root 34. And so now we just need to give ourselves a magnitude of B before we can continue. Same process, taking the square root of negative 4 squared plus 1 squared. So that's going to be the square root of 16 plus 1, which is root 17. Okay, and so we can now chuck that in under here. So we've got negative 17, sorry, inverse cos negative 17 over root 34 times root 17. We will need a calculator to make our lives a little bit easier. What are we trying to get? An angle at the end. Yeah, so there's a couple of different ways you could think about this. What were you going to say, Andy? Might be easier than what I was going to do. Negative 1 over root 2. Yarp. Now, let's have a little discussion. Okay, and we're back. So for those people who are at home, we just spent about 10 minutes. We came up with a bunch of different ways that we could do it, and we have decided on this as being the simplest. It is a non-calculator way that you can do it, and you actually, you don't need a calculator for the whole rest of the solution. So let's see how this works. We have got cos to the negative 1, negative 17 on top. So the connection that Indy first made was that 34 is double 17. And then we also have to remember our rule that the root of AB is equal to the root of A times the root of B. So if we do that one a little bit backwards, we can have a single root on the bottom. We split the 34 into 2 times 17, and then we still have our 17 there. What that allows us to do is with our 17 and 17, you take the root of something that's squaring itself, and it's going to come outside. So we have got cos to the negative 1. We've still got negative 17 on top. And now on bottom, we have a 17 root 2. Next step of simplification, we have negative 17 on top. We have positive 17 on bottom. And that becomes inverse cos negative 1 on root 2. And some people will know that that is very familiar. Now, punch it in the calculator, or what would you do, Josh?
Punch in the calculator.
You would punch it in the calculator. What would you do, Indy? What would you do, Daniel? I know it's your first day in this class, but how would you get from here to a final solution?
So you'd recognise that's the exact value. So I'd draw my little triangles there. I'd have the 1, 1 and root 2 triangle. That occurs when you have angles of 45 degrees. Now ignoring the negative for a second, the magnitude you have is of what's cos, so the adjacent of hypotenuse would be 1 over root 2. So you'd be looking at 1 over root 2, which would put you at your 45 degrees. So I know that there's going to be some form of 45 degrees in my angle. Now, because it's negative 45, and I know that cos is negative, I go to the second quadrant, and I'll go 180, take away 45 degrees, which would leave me at 135 degrees.
135, you reckon, Daniel? How'd you go with the calculator, Josh? Did you get 135?
Yep.
Well done. Okay, that was 7. I don't think we're going to do 8. We've done that kind of skill before. So what we want to have a look at now is questions 9 and 10 that both refer to the same vectors A and B. So we're going to have a look at some resolutes to finish off the day. Oh no, we said we were going to do a midpoint, didn't I? See how we go for time, guys. Alright, so I need some new vectors, and then let's go.
How are you doing, sir? No.
You're doing A. So I've got vector A. Has somebody got it in front of them? Read it out to me.
Determine the scale resolution.
No, I need vector A.
Vector A is I take 2j.
I take 2j, and vector B,
2i plus 3j.
2i plus 3j. Okay, thank you. The other thing I did, I'm not sure if I've got it with me. I should have it somewhere. Getting this close to the exam, guys and girls, I highly recommend that you all have your copy of the formula book that you'll be given for this exam, just so you can double check. I also want to start referring to it, just so that we're having a common language about exactly what we're using and how we're using it. Now, I printed it out and had a copy, and of course it's right in the front of the book. We don't care about calculus. We're not doing complex numbers right now. So I'm looking at the section that has vectors and matrices. You should all, I see Indy's already got her copy. Get this off QCAA. I might email it out to the class as well. So having a look through here, guys, can you see anything about a resolute? You have written your own formula sheet. Okay, that is not going to help you when you're going to need to rely back on it. Because what I'm looking at is there is no resolute rule for you. B hat times A hat? We've got to be really careful about the wording of it here. Really careful about our wording. What are we doing, sorry? It is A on B. So if we're doing, I'll write this in just for everybody, we're doing resolute of A on B. So what does that mean that we need? A hat. A on B. Oh no, sorry, you're all right. Yep, we're doing A on B this time. So we need the unit vector of B multiplied by vector A. First step, work out unit vector of B. All right. How do we work out the unit vector of something? What's that? Come on, Josh, we just did this one. Unit vector.
The product of
Vector divided by its magnitude. Okay, so you see, we're trying to do the resolute. Before we can do the resolute, we need to get the unit vector. Before we can do the unit vector, we need to get the magnitude of B. That's just going to be our Pythag of 2 squared plus 3 squared, giving us root 4 plus 9, giving us root 13. So we have a magnitude of root 13 there. I don't think of any easy ways to break that one down. If someone else can see one, let me know, but I think root 13 is going to stay as a root 13. Okay, so with that, that allows us now to calculate our unit vector for B. So the unit vector of B is equal to B divided by its magnitude, which is going to be equal to 2i plus 3j all over root 13. don't like having roots on the bottom, so we'll follow that process out. Multiply top and bottom by root 13. So we get root 13 outside of 2i plus 3j, all divided by 13. It's going to give me a unit vector of root 2 root 13 I on 13 plus 3 root 13 j on 13. Last but not least, we need to actually do the resolute. So we're going to do our unit B multiplied by A. Unit B we've now got down here. Sorry, our unit vector B. 2 root 13 I on 13 plus 3 root 13 j on 13. What are we doing? Multiplying by A. Sorry, we're doing the dot product of I minus 2j. And I think I can tell from my mark on the board that I've come a bit too far. I'm going to have to redo that working, guys, so people on the video can see me. Let's get rid of this part because we probably don't need that anymore. And we'll just follow on. Okay, so that's going to equal, let's write that out again. I had 2 root 13 plus, plus 3 root 13j on 13, and then we're going to dot product this anymore with vector A, which is your I minus 2j. So I can now see why we might want to go about this another way, but anywho. So we're going to add a 1 to that, which would be the equivalent of our 13. So we want to have 15 on top, 15 root 13 on 13. Because we're doing a dot product, we get rid of our i's and j's. And then we're going to want to, we've got a negative here, guys, so it's going to end up being a subtract. We're going to subtract. We've got 2 lots here, so 2 13s are 26, plus your 3 gets you 29. Okay, and we've got 15 minus 29, negative 14, root 13 on 13.
Sorry, sir. Negative